Hello everybody. What we're going to look at today is opinion forming within networks. And here we have a very simple mathematical model put together by Professor Adamic at the University of Michigan, which shows us how opinion can travel through a network and what the differences are between a random network and a network that has some sort of community structure. So what you see here on this mathematical model is we have a 10-node network, and that network can either be configured to be in a community structure, which is what you see here, or we can take community structure off and set up something that's just completely random, where the nodes will connect to each other randomly. If I go back to here and we'll just look at these two communities, you'll notice that every node in this community here is connected to every other node within the community. And within network science, we call this a clique. And this network here is similarly set up as a clique. And you'll see these types of structures in real-world social networks and organizational structures for companies in our everyday life. Alternatively, if we set this up random, then these nodes are just going to connect to other nodes at random, and there's no community structure here. Now we have two different types of opinion in this network. One is represented by red and one is represented by blue. And for each time stamp of the clock, every node will look to see what opinion do its neighbors hold, and if the majority of its neighbors are blue, it will turn itself blue. If the majority of its neighbors are red, it's going to turn itself red. And if it's equal, it's going to flip a coin and determine, based on a coin flip, whether it's going to go red or blue. So let's just play this out and see what happens. So here we have our random network, and we're going to update the opinion by clicking this Update Opinion button. And you'll see here now, here's the nodes starting to change their opinion. And as I click, you can see that the number of red and blue cells, nodes, changes. As I click, you can see the number of red and blue nodes change, and if I keep clicking, eventually we come to a solution where everything has gone red, and you'll see here it took 15 timestamps to do that. So let's do that one again. We'll reset up as a random network, and I'll just click on Update Opinion until we come to a single solution. Sometimes this will happen quite quickly. And here we can see, there we go, finally it took 40 attempts. Let's try this one again. We'll update. And away we go. We still have one red, one left. There we go, 35. And theirs was a very fast one, only 8 timestamps before everything went red. So I can play with this model for a period of time and see how long it takes, and typically I'm going to get answers that vary between 10 to maybe 30. So now let's put a community structure in, and we'll set up, and let me just click the layout button to make that one a bit clearer. There we go. We have the two communities, and you'll see they're linked by just these two nodes here crossing over the communities. So let's see what happens with this scenario. I'll start clicking Update, and we'll see how many times it takes before our network converges on one opinion. So we are coming up over 60 now, and what you, I think, are observing is how the opinion is bouncing around within the communities, and maybe one community is all red and one community is all blue, but the whole network is not changing colour. So we've got to 130 and it's not resolved itself yet. Let's reset up and we'll try again. Maybe that was just a bad result, and it should have resolved earlier. I will click away and keep clicking away quickly. And I think you can see that we're seeing a similar sort of behavior as last time. We're up into the 70s, and I'll click away fast, and we're over 100, and it still hasn't resolved. And I'll set up again. And if you keep doing this and playing around with this model, you will occasionally see this network structure resolve into one color. But most of the time, what you will find is you will get over 100 clicks and the situation has not yet actually resolved into one single opinion. So what does this actually mean for us in terms of the real world of business? Well, if you think about those red and blue opinions as rolling out a change within an organization, and these community structures be representing part of an organization, then as we all understand, if you do no change management, you can sometimes get a change to work. But the chances of it are fairly small. The majority of the time, what happens is you get incomplete change. You get one part of the community that will change and another part that won't change. And of course, what change management is then attempting to do is to understand where these network and community structures lie and who the key stakeholders are there, so that you can actually try and influence how fast the change is going to diffuse across the network. And you can identify some of these very resistant structures and perhaps put special tactics in place to help them migrate to change. And within network science, we will call this a clustering coefficient. And you will see within large networks, sometimes you have perfect cliques where everybody is actually connected to other people, but often you will have imperfect cliques, maybe of 10 or 20 nodes where everybody's connected to 70% of those nodes. And those are the types of structures that typically you will find to be very change resistant. And I think, as you can see from this mathematical model, you can actually demonstrate that quite nicely in theory. And there's a definite correlation between what we see in theory and what we actually experience in the real world when we try to roll out change. So I hope that was interesting. It was just a very short demonstration of opinion formation within either a random network or within a network that exhibits community structure. Thanks for watching.